Hi everyone and welcome to MathSux. This video is going to help you pass the Algebra 2 Common Core Regents. We're doing this one question at a time. Here's our last question, question 37. Sarah is fighting a sinus infection. Her doctor prescribed a nasal spray and an antibiotic to fight the infection. The active ingredients in milligrams remaining in the bloodstream from the nasal spray, N of T. So here we have N of T, so we know that this is the nasal spray. And the antibiotic A of T, so this is the antibiotic, are modeled in the functions below, where T is the time in hours since the medications were taken. And now we have our question in here. Determine which drug is made with a greater initial amount of active ingredient. So justify your answer. So that word initial means that we're going to be plugging in N of 0 and A of 0 for each. So we're going to be plugging in T equals 0 into each function and seeing which value is higher in order to see which has the greater initial amount. So we want to do N of 0 and A of 0. So let's plug in N of 0 first. We have 0 plus 1 all over 0 plus 5 plus 18 all over 0 squared plus 8 times 0 plus 15. So this gives us 1/5 plus 18 over 15, and plug this into your calculator or do it the long way and we'll get 1.4 milligrams. So now we want to see if the antibiotic amount at the initial stage of 0 is going to be greater than or less than this initial amount. So let's plug this in. We have 9 over 0 plus 3. So I'm just plugging in 0 for T here. So this gives us 9 divided by 3, which gives us 3 milligrams. So we can see that 3 milligrams is greater than 1.4 milligrams, so we know that the antibiotic has a higher initial amount. So we're going to have to write this in words. We have to justify the answer, so just to write a little sentence here. So just a quick sentence, the antibiotic has a greater initial amount since it has 3 milligrams compared to 1.4 milligrams. So we have a follow-up question. There's a part 2 to this, question 37, where it says, Sarah's doctor told her to take both drugs at the same time. Determine algebraically the number of hours after taking the medications when both medications will have the same amount of active ingredient remaining in her bloodstream. So when we see when both medications, determine algebraically the number of hours after taking when both medications will have the same amount of active ingredient. So we want to basically do simultaneous equations and set these equal to each other. So we want to set N of T equal to A of T and see what T is equal to. So N of T is T plus 1 over T plus 5 plus 18 over T squared plus 8T plus 15. And then we're setting it equal to A of T, which is 9 over T plus 3. And I just got these values from the previous page, so I didn't do anything fancy here. So we're just setting these equal to each other, and now we're just going to want to solve for T. So to do that, we're going to want to use product sum and factor this. So we have T plus 1 over T plus 5 plus, and now let's just put this on the side here. Let's do a little product sum. If we have P is equal to 15 and the sum is equal to 8, we need two numbers that multiply to 15 and add to 8. So this will be 5 and 3. So now we can rewrite this. We have 18. And then now we're going to rewrite this factored. This will be T plus 5 times T plus 3. And then this is equal to, this will stay the same, 9 over T plus 3. So now notice we want to get these to have a common denominator across the board. So we have T plus 5 times T plus 3 over here. So over here, notice on the denominator we're missing T plus 3. So that means we're going to multiply the top and bottom by T plus 3. And then over here, we're going to do the same thing with the missing binomial, which is T plus 5 on this side. So T plus 5 over T plus 5. So when you distribute this, we get T squared plus T plus 3T plus 3 all over T plus 3 times T plus 5. So we just distribute these two, and here we're going to leave the same because we're going to get rid of that soon enough. 18 will stay the same. This whole fraction will stay the same, t plus 5 times t plus 3. And then here we need to distribute 9 to each term in t plus 5. So that gives us 9t plus 45 all over t plus 3 times t plus 5. So now that we all have a common denominator here, we could basically just drop that off and get rid of it. So when we rewrite the numerator up here, we're going to just want to see if we can combine any like terms. So t squared plus t plus 3t will give us 4t, and then 18 plus 3 will give us 21. So so here we combine t plus 3t to get 4t, and then 3 plus 18 to get 21. And then now we have, on the other side of our equal sign, we have 9t plus 45. And now this looks like a regular quadratic equation, so we can just move 9t over to the other side and 45 to the other side. And when we do that, we get t squared minus 5t minus 24 equals 0. So now we can use product sum to solve this. We have p equals minus 24, s equals minus 5. So we need two numbers that multiply to negative 24 and add to negative 5. And we end up with negative 8 and 3. So we can rewrite this equation as t plus 3 and t minus 8 equals 0. Do a little factoring magic, we get t plus 3 equals 0, t equals negative 3. And then here we can see t is equal to 8. So remember what t stands for. It stands for the number of hours, right? So if we are working with hours, we cannot have a minus 3 hours. So we're going to reject this because that does not make any sense. So our answer here is t equals 8 hours. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!